Now, the next example we're going to look at is going to illustrate something that's very important to keep in mind when solving radical equations. And that is this, that when you raise each side of an equation to a power, it's very possible you may introduce extraneous solutions in the process of solving. So it's going to be crucial when we solve radical equations that we check the possible solutions we get at the end back in the original equation. Now, for this next example, we have the square root of x being equal to the opposite of x. So let me rewrite the equation here again. And since we have square root on the left-hand side, what we can do then is raise each side of the equation to the second power to eliminate the radical. So we'll have then on the left-hand side x, and on the right-hand side that will be x squared. Now this is a quadratic equation, so what we'll do is make one side 0, and I'm going to choose to keep the x squared term where it is and make the left side 0, so then we will have 0 is equal to x squared minus x, so we're simply putting the equation into standard form. And this equation will easily factor, so we'll have then 0 is equal to x times the quantity x minus 1. So the possible solutions to this equation would be x is equal to 0 or x is equal to positive 1. Now keep in mind, those are possible solutions. We need to be sure that they are valid by checking them back in the original. So what we'll do, let's check first x equal to 0. So we put 0 back into the original equation. We have the square root of 0 being equal to the opposite of 0. The square root of 0 is 0. The opposite of 0 is 0. So that value checks. So we will next then check the possible solution x equals 1. And putting that back into the original equation, we have the square root of 1 being equal to the opposite of 1. And the left side then simplifies to 1, which is clearly not equal to negative 1. So the possible solution x equals 1 does not check. So the only valid solution to this equation will be x equal to 0.